So hello everyone, in the last session we have completed all the calculations regarding equivalent resistance. Basically we have completed our circuit theory part. Now you can solve any circuit from any book, whether it is SC Verma or any coaching institute book, whatever you want you can take and you can solve the circuit. I hope you are able to solve all the questions. So let us now, we will discuss about some small units which are left, and then we will discuss about the electrical instrument, and that is about the last portion of our chapter. So let us start. In this session we are going to start with the calculation of electric power. Basically we have to understand what is electric power. Okay, so let us start with the electric power. Okay, so what is electric power basically means, what is the definition of it, and what is the meaning of it. See, first of all, if you talk about the current, okay, first of all, or let us see, we have seen resistor now, so let us talk about this. Suppose it is a resistor, okay, and suppose I have a small charge dq, okay, and suppose here it is I have applied a one battery, okay, suppose I applied a battery here, okay, suppose the potential is B, so we will take this as V, this as 0. Initially suppose the charge dq is here, okay, so what is the energy at this point? The energy will be, obviously we know from the electrostatic potential, what is the energy? Energy is nothing but a work done, or you can say it will be V dV, correct, V dq, correct, that is the energy at this point. What is the energy at this point? It will be become, here the energy will be V into what is the potential here? 0 dq, so energy here is 0, correct, here what is the energy is 0. So we can say that here the energy is V dq, but here the energy is 0. So where that all energy has gone? So all the energy has gone and absorbed in the resistor, correct, and the resistor is a passive device. So if it is a passive device means it will absorb the energy. So here resistor has absorbed that energy, correct. Where that energy is gone? Because this resistor has absorbed that energy, correct. So what is the heat release? Because resistor is a passive device, it will not store that energy, it will obviously absorb that energy, and what it will do, it will absorb that energy, then release in form of heat, release in form of heat. So if I ask you what is the heat release, dH, small heat dH, it will be something what? V dq, correct. And if you want to calculate the total heat, what you will do? Just do one thing, multiplied with dt and divide with dt. So what is this thing? Can you tell me? What is this thing? What is this thing? This quantity? This quantity is nothing but what? That is a current. This is a current. Remember, this is not a normal current. It is a current in R, okay, in resistance R, okay. So what is the H or heat you will get? H is equal to integration I into V into dt, correct. That is a value. So let me write it here. So what is what we have got? The heat, we have got that the heat released will be how much? It will be nothing but integration of I V dt, and for resistor, this is for resistor I am writing only, okay. For resistor we know what? We know, sir, V is equal to IR, correct. So I can reduce this equation into I square R dt, correct. So that is my total heat release in a resistor, clear. That is my total heat release in a resistor. But we are talking about electric power, sir. Why we are discussing heat? Let us first know this formula, then we will come to that electric power. First you should know the formula, that what is heat release. So this is the amount of heat release in a resistor, correct. So that is the amount of heat release in a resistor, clear. Okay, That you remember. Now how the electric power is defined? Electric power is defined as rate of rate of rate of doing work, means rate of doing work, that is called as my power. What is electric power? Then what is electric power, sir? This is power. Okay, then what is electric power, sir? What is electric power? That is a rate of doing electric work. Power means rate of doing any work. Electric power means rate of doing electric work. So if we want to define a power, then what we can say? See, with if you go with respect to the resistor, or we are not going with, let us take a general case. So how the electric power is defined? Electric power for any circuit, this is true for any circuit, because lot of people are confused. Electric power is basically defined as, remember, it is defined as I into V. Okay, that is power P is equal to I into V. True for anywhere. True anywhere. This is true for anywhere. But if I want to, this is my power, but if I want to find instantaneous power, but this formula which you are writing, like I square R or power is equal to V square by R, these formulas are valid. Sorry, excuse me. Yeah, these formulas are valid for resistor. Okay, these formulas are valid for resistor. So what is electric power? Now what is the unit of this? What is unit? See, the unit is defined as watt. Okay, the unit is defined as watt. Clear? The unit is defined as watt. Till here, note it down. Clear? Now what is this type of quantity? It is a scalar quantity. First thing, it is a scalar. It is a scalar quantity. So a scalar quantity means what does it mean? It will be positive, 0 as well as negative. All three combination will be positive, possible, sorry. Then the question arises, how we will decide the power will be positive, how we will decide the power will be negative. Let us understand this. That is a very simple method. Suppose, simply there is simple rule. Suppose there will be some element, okay, it can be anything, okay, it can be anything, it can be anything. Anything means resistor, capacitor, battery, anything, okay, it doesn't matter, it can be anything. Clear? It can be anything. And suppose this is plus, this is minus, and current is going like this. Okay, if current is entering to the positive terminal of the battery, here it will be absorbed, and that is positive. Clear? And just take it as opposite of this. This is the only confusion the student have. I am clearing the all confusion. Just it can be anything. Okay, remember this. Just listen my all the points. It can be anything. Okay, suppose this is plus, this is minus, and current is entering in this case. In this case, the power is sorry. Here the I have written opposite. Let me correct it. Sorry, by mistake it happened. Okay. So suppose the current is like this, then it is a power. No, I have written correct only. Here the power is absorbed, it is positive. And suppose the current is like this, then in this case the power is delivered and it is negative. Just you remember this concept and follow this concept everywhere. You will always get the correct value with the sign. You will always get a correct value with the sign. Okay, when the power is absorbed, when the power is delivered, it will be always correct for you. Okay, let us see some examples. So I hope you understand what is electric power. There is one more thing is there, that is a unit thing, unit conversion. Basically a lot of students are getting confused in the unit. Let me clear it. See, the unit conversion is very simple. You know 1 watt, you know what is a unit of power. That is very important. Unit conversion, that is 1 unit. 1 unit means how much? That is equal to 1 kilowatt per hour. Okay, that is 1 kilowatt per hour. Now if you will convert into the joule, basically they will ask you to convert into the, so 1 kilo means 10 to the power 3 into watt, you know that is, leave it like this. What is hour? Hour you will convert 1 kilowatt per hour, so hour you convert into the second. Just convert the hour into the second. Basically you want to convert it into the joule now. So what you will do, you will remove this hour, so you will multiply it with 1 hour. 1 hour is how many seconds? So that is 36, I think, yeah, 3600. So if you will do this, you will get 3.6 into 10 to the power 6 joule. So remember, 1 unit is equal to 1 kilowatt hour, that is equal to 10 to the power 3 watt hour, that is equal to 3.6 into 10 to the power 6 joule. And remember, 1 calorie is equal to 4.2 joule. That is also one important relation. Okay, so these are the unit conversions. These are the unit conversions. If you remember, you can easily solve the question. Sometimes they will give you the like things in they will ask you the things in joule, so it is better you remember this thing. Clear? Any doubt? Okay, so let us now see the some example. Okay, just I'm moving to next slide. Now let us see the some example. So as we have seen lot of before going to like let me ask you a simple question. Let us suppose this is a resistance of 2 ohm. The current here is flowing is 2t square plus 3. What is my question? Find heat released at t is equal to 2 seconds. How will you solve? Find the heat released at t is equal to 2 seconds. How will you solve? So simple, you know what is heat release. H is equal to integration from 2 seconds. You are talking about, so t is equal to 0 to 2 seconds, correct? I square into r into dt, correct? Now what is I square? Just do the square of this or make it little simple, otherwise it will be very 2t plus 3. Okay, just I'm making it simple little for the calculation purposes. So 0 to 2, what is I square? That is 2t plus 3 whole square, correct? What is resistance? That is 2 ohm into dt. Now you do this, so what you will get? 2, this will become 3 divided by 2, 2t plus 3 whole power 3, that is 0 to 2. So what is the value you will get? You will get 1 by 3. So 4 plus 3, that is 7. 7 cube is how much? 343 minus you will put 0, so you will get 3 cube. 3 cube is how much? 27. So what is the value you will get? Sorry, this will be not divided. So when you do this, 343, sorry, 1 minute. Yeah, I'm doing correct only, na? Yeah, 4 plus 3, 7, cube is 49 into 3, that is, oh sorry, this is wrong. It will be not 433, 44, because 7, okay, no, this will be 343 only. So 3, okay, cube 27, 13 7. So how much this will be? So let me this value will be how much? 1 1 3 1, how much is 13? 13 4, okay, and 3 minus and 27. So how much you will get? 14 means 9 5 0, okay, 105. No, not watt, because it's a power, a type of energy only. So 1 watt, this much joule. Okay, so if I ask you to convert it into a 1 unit, what you will do? You will divide by 3.6 into 10 to the power 6. You will get 1 unit. Clear? So this type of question maybe I ask you. I can ask you like this also. Like any complicated circuit I can give you. Like suppose I can give in the same question. Suppose I will say this is 1 ohm and the current here is sine 2t. Okay, and t is equal to 3 seconds. Can you find the heat released? You can solve, no problem. Basically it is a question of AC circuit. We will see how to solve this question, but you can solve directly also, no, because you know this formula. This formula is everywhere applicable. That is the general formula. Apply it here, you can solve. So take it as a homework. Okay, take it as a homework. So you can solve like this. So we have discussed till now like how to calculate the heat released in any circuit element. First thing, this formula you are writing, this formula is valid only for resistor, but this formula which we have written, this formula is we have written, it is valid everywhere, but for resistor if you talk about, then you have to go by this way. Okay, second thing, we have talked about electric power. Electric power is nothing but just rate of doing work. This formula is valid for everywhere. For battery also, if you ask, you have to apply this thing, and but for resistor you have to go like this. And how to decide where the power is positive or negative? You have to see the, for any element you see the polarity, and then you see whether it is current going inside or current going coming outside. If it is like that, you can decide whether the power is delivered or absorbed. Okay, or you can, what will be the sign of that power, correct? Now let us, there are some rules are there, but we are not going to the rules because that is not important for our exam point of view. Okay, that you will discuss if you go to discuss particularly the circuit theory in your highest, but till now what we have covered, that is more than sufficient. Okay, now there are some special problems they ask you in the exam. That is basically what you can say, that is basically they will give you some circuit like this. Let me take one example, then it will be clear. Like they can give you anything. Now I can frame any type of question, like suppose like this. They will 8 volt of battery is there, and suppose there is a one resistance of 3 ohm, okay, 2 ohm, and suppose there is a one more battery like this 2 volt, there is a one resistance of 3 ohm, and I ask you what is the power by 8 volt, what is the power delivered by the 8 volt battery? Power deliver, remember I am asking power delivered by the battery. Clear? How will you solve? Basically, how will you solve? What is the approach? See, basically if you want to find the power delivered by 8 volt, what you will write? You will write what is the voltage? The voltage is 8 volt, correct? And what is the current I? So what is your aim? Basically your aim is to calculate that I. And how will you calculate that I? That is a simple, again same circuit theory. Now you have to apply the same circuit theory here and whatever we have learned. So basically it is not a question of power, it is a question of what? Circuit theory. So that is why I have discussed a lot of classes, I have taken a lot of classes to discuss about circuit theory. So if you know the circuit theory properly, then there is a, like this type of question is nothing. They will simply ask you to calculate the power. If you know the current and voltage and resistance, or if you know the current and voltage, you can directly tell the power. So how will you solve? Simply, what is the approach to solve this type of question, this type of circuit? See, it is not, if you, what is the approach? Take any 1.0. So if this is 0, this will be 8 volt. This you don't know, so you just take it as x. If this is x, this is also x, and this will be how much? Less than 2. X means x minus 2, because we are getting lower potential, so x minus 2. That is the method I have told you, simple. Now what is it? You will apply the KCL at this node. So what you will write? X minus 8 by 3, correct? X minus 0 by 2, correct? X minus 2 by 3. See, it doesn't mean that I can solve it only in this method. There are a lot of other methods also, but for you that is the most suitable method. Multiply by 6, you will get 2x minus 16, then you will get 3x, then you will get 2x minus 4. So what is the value you will get? That is 7x, correct? And what is the value you will get? That is 20. So what is the value of x you will get? That is 20 by 7. So can you tell me what is the current I? Yes sir, I can tell. That is 20 by 7 minus 8 divided by 3. But remember, this current we are taking like this. If you want to write I, you have to write in minus sign, because that is opposite of that current. Okay. So what is the value you will get? 8 minus 20 by 7 divided by 3. So 7, 8, 56. 56 minus 20, how much? That is 36, correct? 56 minus 20 is how much? 30. 50 minus 20 is 30, then 6 is left. So that is 36 by 21. That is the current we know. So if you know the current, now you can write the power. Yes, that is how much? Sorry, 36 by 21. So that is what is the value you will get? 8, 6, 48 and 48 and 8, 3, 24. 24 plus 4, that is 28 divided by 21. So what is the value you are getting? 1 and 7. 7 means that is 3. Okay, so 361, that is 63. So this is 78, I think so, and this is 63. 15. Okay, 9 to 18, 8, 3, 27, 13.7 watt. Clear? 13.7 watt. That is how much you will get the current, power consuming, power delivered. This is power delivered or power absorbed. If you see, the power is coming from the positive terminal. So this is the power delivered and it is positive value, correct? This is how much is the power delivered by the 8 volt of battery. Clear? Any doubt? So I can frame any circuit and I can give you, and I can ask you power in all the branch. Simple approach. Okay, simple approach you have to apply, and then you can calculate. Basically here you should know the circuit theory. So if you know the circuit theory, if you have attended my all the classes of circuit theory, now you can solve anything. Okay, I can give you any question like that. We have solved one more question in the last class, if you remember, that cube question. What do you have to do? This is calculation of basically R equivalent here. Okay, there is nothing like big thing is there. If you know if you know all the approaches what we have discussed, you can simply solve it. That is not a big problem. Okay, clear? Any doubt? Okay, I hope till now everything is clear here. So let us now discuss about some problems on bulbs, because that is a very favorite part. Problem on bulb. Okay, there is a lot of problems they ask you on the bulbs. Okay, so let us see what are those problems and how to approach that problems. So let us start with one example. Suppose I have a one bulb and this is in India. Okay, and suppose here we have a rating. The rating of this bulb is 220 volt at 110 watt, or you can say 100 watt. So what is the meaning of this? What do you understand from here? First you have to tell me. If I am writing 220 volt at 100 watt, what you understand from this thing, from this line? Basically we understand that from this line, that if what you understand from here, this is the rating, this is the rating, this is called as the rating of that bulb. So what do you understand? If we give 220 volts, okay, then we get a power of 100 watt from bulb. From bulb means if you are giving up a voltage of 220 volts to the bulb, how much power you will get? You will get output power as 100 watt. That is the basic idea. You can say the basic concept of a power. This is the basic concept of this power rating, which is written here. Okay, for every device there is a power rating is there. Suppose if I am using this device also, there is also a power rating for this. Like if you can see this This is the Bluetooth, basically this is the our speaker we are using, and if you see there is a power rating is also written here. Let me see what is the power rating they have written. Yeah, they have written a 5 volt of voltage, or 5 volt of voltage, and rating capacity is 1410 milliampere per hour. Okay, yeah, this is basically what they have written, the power only, but in terms of milliampere per hour, that is another way of writing the power. And another thing is that the voltage rating is 5 volt. Okay, the voltage rating is 5 volt. They have given the voltage rating of 5 volt, means maximum we can go up to 5 volt, we cannot go up to above more than 5 volt, because if suppose I give you the power voltage of greater than 220 volts, the bulb is blow down, means it will be broken, it will be you can say it will be fused. The maximum we can give it to 220 volt, and how much power it can give, then it will give 100 volt. If suppose I will give you give the voltage as less than 220 volt, then the power will be given is less than 100 watt, obviously, because we are not delivering a 220 volt power to this bulb. So now what is my question? Now from here to here I have, this is in India. Now I went to USA. Okay, I went to USA, and in USA suppose I am delivering to 110 volt. Okay, so what is the power? Now what is my power? How much power it will be? Whether it will be glow with 100 watt? Obviously not. Why? Because at 220 volt we are getting 100 volt. So at 110 volt it will be some other value. So what is that value? I want to know. How to calculate? From here to here when I am coming, what is remain same? See, bulb has a tungsten. Tungsten has some resistance. So the resistance won't change, na? The resistance will remain same. If you see, the resistance will remain same. So what is the resistance here? What is the resistance here? So if you find the resistance from here, we know that power resistance will be how much? Resistance will be simple. Power is equal to V square by R. So resistance will be P upon, sorry, resistance will be, 1 minute. We know that is power is equal to V square by R. So what is my R? R will be from here, that is equal to V square by power. Now what is V square? From Indian standard we know that is 220 volt square. What is the power rating is 100 watt. So what is the resistance you will get? You will get the resistance of how much? That is 448, correct? 448 or 484. I think 484. Let me take 2. Yeah, correct. 484. 1 minute. Okay, this board has some issue with, sometime it get hang. So 448 ohms resistance is there. When I am coming here in USA we are getting the same resistance won't change, na? So what is the power? So what is the power you will get? V square by R. Now what is the VV here we are giving? That is 110 volt. And what is the resistance? That is 22 into 22. I can write like this, correct? If you will do, you will get 50 watt. I'm doing correct or not? Yeah. So it is okay. 10 means 100. So 12 1 2. Yeah. No, not 50. It will be, sorry, it will be 25 watt. So you can see the power is become 25 watt, means the power is reduces. So that is a basic concept. I have given you the basic example so that you can understand all the concepts regarding bulb. Now let us now see what is the exactly the question they are asking. This is the question they won't ask. What is exactly they will ask? Now let us discuss. First case, suppose I have a 3 bulbs. Okay, I connected them in a series. Okay, suppose I connected them in a series. Suppose let's take me some data so that it will be easy for you. Okay, yeah, this is bulb number 1, this is 2, this is 3. Let us connect it with a voltage V, correct? what is a rating of 1? There is a rating of bulbs are given. For first bulb, the rating is how much? That is 100 watt and 220 volt. For second bulb, what is the rating is given? That is 50 watt at 220 volt, correct? And for third bulb, what is the rating is given? That is 20 watt at 220 volt. It's very bad. Okay, so these all ratings are given and they are connected in series with a battery source of V. My question is, which bulb will glow brighter? That is my question. Means which one will grow brighter? Okay, so what is the first thing? See, if you calculate the resistance for this R1, what is the value you will get? V square by P, that is the resistance. What is V square? 220 volt square divided by P, that is 100. What is R2 you will get? Sir, 220 volt square divided by, that is 50. What is R3 you will get? That is 220 volt square by 20. So if this R1, R2, R3, you can see my R3 is greater than R2, that is greater than R1. And you know in series what is same? Current is same, I is same in all, I is same in all, correct? If I is same in all, we know what will be the power. We can write I square into R, I square into R. So if we have more resistance, more power. Okay, if we have more resistance, so more power. So more power means more P means, what do you mean by more power? Means bulb will glow brighter, bulb will be glow brighter, correct? So what I can say from here, which will be go brighter? So obviously we can say power of 3, because the resistance is high, so power of 3 is greater than power of 2, that is greater than power of 1, so 3 is glow brightest, or you can say brighter. That is answer. Clear? So this type of question they will ask you. You have to think like this. Okay, that is a way of thinking. If in the same question, if in the same question, in the continuation, suppose I ask you the same question, everything is same, just what I did, I connected a bulbs, but in spite of connecting them into a series, I connected them into a parallel, correct? A battery of voltage V, everything is same, this is 1, this is 2, this is 3. Now you tell me which will grow brighter for this. All the ratings are same, okay? Here which one will go brighter in this case? In this case what will happen? Sorry, in this case what will happen? What you can say? See, here if we can see one thing, we know that is R3 is greater than R2 is greater than R1. Okay, that we know from earlier of the assumption. Now in this case, if you want to compare the power, we know we will use equation V square by R. Why? Because the potential is same as everywhere, na? So it is easy to compare. Now from here, if the resistance R3 is greater, we can say the P3, sorry, we can say the P3 is less than P2 is less than P1. So 1 will glow brighter, will grow brightest, or you can say brighter, whatever you want, you can say like that. So 1 will grow brighter. So I hope you understand how to see the things in series and parallel and how to think about the things. Basically they will ask you this type of question only, so you should have a knowledge to comment that which will grow brighter and which won't glow brighter. Clear? So let us, what they are now, what they exactly ask, they will ask such type of questions. Suppose what they will ask, there is a one previous year question, okay, this is a PYQ only. I don't remember it is whether it is a PYQ from NEET or JEE, but it is very simple question they have asked you. They given a battery of voltage V, and what they have did, they have told that this is my bulb, sorry, this is bulb 1. Okay, that is a very very old question. Okay, then there is a bulb 2. Okay, then there is a bulb 3, and then there is a bulb, 1 mole bulb is there, and there is a 1 mole bulb is there, and there is a 1 more bulb is there. Correct? This is how they have given, and they have tell that this current is I is there. Okay, and the resistance of all the bulbs are R. This is bulb is 1, this bulb is 2, this bulb is 3, 4, 5 and 6. Now they ask you which one will grow brighter. See, one thing is clear, if this current is I, this is R. See, R, 2R, correct? R by 2. R by 2 plus R is how much? Or let us take, this is at 2R. This is as I am slightly changing the question for the easy calculation point of view. Okay, so that you can do the calculations more easily. So let us, this is at 2R, correct? So what this 2R will be R will be 2R, correct? And this is also 2R parallel with R. 2R parallel will become R 2R. So net resistance is 2R. So how much current will flow? Current will flow how much? That is V upon 2R. That is a current we got. Now this current will come here and it will divide here equally. Why? Because here also we are getting 2R, here also we are getting 2R. So this will be I by 2 and this will be also I by 2 here. Correct? Now here again it will come and it has to divide. So it will divide into I by 4 and here also it will go into I by 4. Correct? And what is the current in this branch? In this branch it will be I by 2 and from here also I by 2. So from here what is the current? I. So now if I ask you what is the power of every bulb, so what is the power of first P1? So if you will see, the power of P1 will be I square into R, correct? Similarly, what is the power of P2? P2, what is the current in this? That is I square by 4, that is I square by 4 into I square by 2, sorry, so I square by 4 into R. What is power in P3? P3 will be same I square by 4 into R. What is the power in, sorry, P4? P4, if you will see, that is I square by 16 because I by 4 current is there into 2R. That is how much will become I square by R divided by 8, correct? Similarly, what is my power in P5? So if you will write the power in P5, there is current is I square by 4 into R, correct? Similarly, if you want to find what is the power in P6, so what you can say, that is current is I square by 4 into 2R, I square by 4, like I square by 16 it will become into 2R, that is I square by R divided by 8. So now if you can arrange in the terms of what power, what you can write, because I value is same for everywhere. Okay, so if you write in the terms of power, so which will have a highest power? Obviously P1 is greater than, so P1 is the highest, means it will grow brightest bulb. This is the brightest bulb in all this. And then after that, if you will distribute, you will write like this: P2 is equal to P3 is equal to how much? P5, and that is greater than, this all are greater than which one? That is P4, that is equal to P6. So this is the basically order of this power consumption. So this type of question they used to ask. Okay, so you should have a clear idea of series and parallel combination and circuit theory. Then you can directly tell that which one will grow brightest and which one won't glow. Clear? Any doubt is there till here? You can tell me. Any doubt is there? Okay, no doubt, everything is clear here. Okay, so this is about the electrical power basically. Clear? For your point of view, this much is sufficient for your point of view if you have to solve the question. Now our next topic we are going to start is something called as a maximum power transfer theorem. Okay, so next topic is very important, it is called as a maximum. See, most of the people will teach you maximum power, but in reality it is something else. We will understand it what is exactly, and we will see how to solve the question. It is called maximum power transfer theorem. What is exactly its mean? Let us try to understand. Basically, they will say, suppose there is a some voltage source is there, voltage source, some voltage, or you can say that in your term, let us suppose, sir, there is a some battery. The battery value is volt. Okay, okay, sir, no issue. Let us, sir, I put a one resistance here, R, and there is a some load resistance is there. That is called as a RL, sir, load resistance. And the important thing is that and the important thing is that this resistance is variable. This is called variable resistance. Means this value is going to be vary. If this is the case, can you tell me what is the current in this branch? Yes, sir. The current is very simple. V upon R plus RL. Correct. So if I ask you what is the power consumed in the RL, what is the power absorbed in the RL? Because it will absorb the power obviously. So what is the power consumed? That is I square into R L. So if you put this value, what you will get? You will get V square into RL divided by R plus RL whole square. Correct. This is the value you will get. Any doubt here? I square into RL. So this is the power consumed you will get in this load resistance. Now I want to find value of RL so that PRL will become maximum. Means there will be maximum power will be transferred. So what is the idea to do this? The idea is very simple. You have to do you have to do what? You have to do dP RL divided by DRL equal to 0, because you know in mathematics whenever we have to find the maximum of anything, we have to differentiate that function and put it equal to 0. So just differentiate this. When you differentiate, what you will get? This is my R plus RL whole to the power 4, then R plus RL whole square. First you differentiate V square. V square is a constant, so this will become 0 into, obviously that is a constant quantity. Then we have RL. Oh, sorry, but I did something wrong. Yeah, sorry, I did something wrong. 1 minute. This is my V square, this thing. Then you have to integrate differentiate the V square is constant, RL differentiation is 1 obviously, minus, then you have to leave this V square into RL into differentiation of this thing, so it will become 2 times of R plus RL into differentiation of RL is 1, that is equal to 0. Now if you solve this equation, solve this thing, so what you will get? You will get my R is equal to RL. That is a condition you will get from here. Means for R is equal to RL. So when the R is equal to RL, then my P max to whom? RL is equal to how much? That is V square upon 4 times of RL, or you can say V square upon 4 times of R. Okay, this is the maximum power transfer theorem. Okay, that is a proof, you know, everyone know this thing. Well, but we have to understand what is really it is. So let us now try to understand. See, this is the proof, everyone know what is the maximum power transfer, what is the efficiency. If I ask you what is the efficiency here, if I ask you what is the efficiency here, can you tell me the efficiency? Yeah, you can tell. Efficiency is what? What is the output power? Output power is this much, V square by 4 RL. What is the input power? Input power is how much? What is input power? That is V upon, input power is V square upon 2 RL. Correct. So what is the efficiency? That is 50%. Correct. Maximum efficiency is 50%. Means whatever the power you will get output power as 50%. Clear. And lot of things, other things are also there. They will ask you the graph, to draw the graph of, they will ask you simple graph. These all are theory question. I will tell you. I am not saying I won't tell you. This is all are theory things. If you want, you can remember, but no one is going to ask you these things in exam. In competitive exam, they won't ask you this type of things. Okay, if I ask you what is a graph of efficiency versus RL, what will be the graph? The graph will be something like this. Okay, maximum efficiency we are getting is 50%. What is the graph of power, maximum power transfer? P versus RL. So you can see that maximum power will be transferred when my R is equal to RL. Okay, that is my maximum power transfer. What is the value? V square upon 4RL. That is all everyone will know. That is, leave this thing. Okay, that everyone know this thing. My important perspective is that how will you solve the questions? What is the approach to solve the question? What we have to understand from here? So let us understand this. Now I am going to discuss very important thing for 10 to 20 minutes. Your focus should be clearly here. Just leave your pens and try to listen properly. Basically, any battery, if you see any battery have some resistance. That is always true. Okay, any battery has some resistance. It is not ideal battery. Okay, basically it will be something like this. If you see, it will be something like this. This is a battery, and inside this battery there is a small resistance R is there. Okay, this is my V value. But if you draw like this, it will be not easy to understand for us. Okay, it is not easy to understand for this thing. So what is we used to do? We used to convert this thing into, for circuit solving, for solving the circuits, for solving a circuit, what we are going to do? We are going to convert it into this thing, this way. This is V, this is R. So is this thing, can we handle this thing? Yes, we can handle. We know how to approach this type of things. Okay, because it is normal combination of battery and a resistance. It is not something like this. So that is what we are going to do for solving the circuit. We are going to combine this thing into, convert this thing into this thing. Clear? So if I give you the circuit like this, suppose, so there is a battery, there is a small resistance R is there, this is my capital R, and suppose this is my R is there, RL is there. Okay, that is again variable. Okay, so if I ask you what is the condition, then the condition is RL should be equal to small r. And what is the maximum power transfer will be there? Then P RL maximum, if I ask you, then what you will tell? You will tell, sir, it is V square upon 4R, or you can say, sir, V square upon 4RL. So basically what we have understood from this whole discussion, there is a lot of more things to discuss, but till here what you understand, I have just, means you can say that, sir, this R is nothing but an internal resistance of a battery, or it can be any resistance. It is not sure. It is not always true that it will be always an internal resistance. But if you read the book, if you read any material, what they used to tell, for a maximum power transfer, my total resistance of the load should be equal to the equivalent resistance, equivalent internal resistance of the battery. Is this always true? Answer is no, it is not always true. It is not always true. So what is the approach then? What is the correct statement then you have to remember for the maximum power transfer? Because this is the general approach. This is the general approach. This is the special case. It may be that it can have an internal resistance, it cannot have an internal resistance. So then you have to simply, what you have to do, you have to convert this into this form. Then it is normal solving a circuit. Okay. So what is the exact statement of maximum power transfer? How to solve the question? What is the approach? So let us see the approach. Let's understand the approach to solve questions of maximum, or you can say MPT, that is maximum power transfer theorem. MPTT, that is maximum power transfer theorem. What is the approach? Simply what you have to do, any type of circuit is given, any type of circuit. Okay, there are 3 steps are there. Okay, step 1, any circuit is given. Let us talk about any circuit. Okay, any circuit. First you have to see what? First you have to see one thing. Any circuit, first you have to see if R, small r means internal resistance of battery. Small r means internal resistance is given or not. Or not. First you have to see this thing, whether internal resistance of battery is given or not. Suppose if it is given, two cases will be possible. What are the two cases? Either R will be given or either R will be not given. Correct? If R is given, what you have to do for solving the circuit? If R is not given, what you have to do? If suppose R is given, then you convert this thing, if circuit, write it like this, a battery into small, and just here you write small r. Okay, suppose there is some big circuitry is there, you simply write it as R is a battery and small r. Clear? And if R is not, means R not given, means if R is not given, R is not given, then what you have to do? Then no need to draw this, then no need to draw this thing not required. Okay, it is required here, you have to draw this. Okay, draw this. Okay, in the circuit only you have to draw this. After that, what you have to do? Find, then after these two steps you have to find one, you have to do only one step. After this step, calculate R equivalent from RL, that is variable load across variable load, not from variable load, sorry, across RL, or you can say variable load by making by removing battery by wire. Simple. Now let us first, so that is a flow you have to follow to solve the question. Okay, that is a simple flow you have to follow. This is the flow to solve the question. Flow chart. That is a flow chart you have to apply to solve any question in maximum power transfer theorem, and that is the exact method. That is the exact method. If you go in highest, it will be more clear. They will tell you the more exact way. But this is the, like, this is the almost 90% I have told you what is the exact method. 10% they will give you the more idea about if there is a current source and all that. But you just remember this thing you have to apply. Let us see one example. Let us see one example. 1 minute. Yeah, let us see one example. Okay, so let us consider there is a, let me see one question if they have an example any. Yeah, so suppose there is a battery of 10 volt and suppose it has a 3 ohm of internal resistance. This is my internal resistance. Okay, this is 5 ohm, this is 3 ohm, and this is some RL. You have to find, first is RL for P max and how much is the value of P max. That is all the things you have to calculate. So what is the approach? First method, step 1. What you have to do basically, you have to first see whether there is an internal resistance. Yes, and they have given the value and they have also drawn it also. Okay, generally they will draw. Okay, so what you have to, that step is till here. If you see till here, everything is done here. You have to directly go to this step. What is this step? How to apply? Because that is only crucial step. First, what is the thing you have to do? You have to calculate the R equivalent across RL. Means what you will do? You will draw the same circuit. Now you will remove the RL because you have to calculate the equivalent resistance. So you will remove it and you will draw the circuit 5 ohm, and you have to replace the battery by a wire. So replace it by a wire. This is my battery, I replace it with the wire. This is 3 ohm and that is what you got. Now if you see from here, what you will observe, see 3 ohm and 5 ohm, they are in. If you see properly from here, what you will see, sir, this all resistance are in series. If you try to see 5 and 3, if you will see, they are in series, correct? 5 and 3 in series, that will be 8 ohm, and 8 ohm is also series with 3 ohm, correct? So I can say, what is my RL? My RL will be simply 5 plus 3 plus 3. That is how much? 33665 11 ohm. So this resistance should be 11 ohm. So for a maximum power transfer, my net resistance should be equal to 11 ohm. Correct? My net resistance should be equal to 11 ohm. Okay? Some people will tell you what? You just keep the equivalent resistance of this should be equal to 3 ohm. But no, that is wrong. You have to simply apply this concept. This resistance should be equal to 11 ohm, and that means that will be our RL. So what is my P max? P max, that is V square upon 4 times of RL. So what is V value? V value we have 10 volt divided by 4 into 11. So something you will get that you will calculate. This much watt. Basically this much watt. Clear? So this is how we apply the maximum power transfer theorem. That is a simple step. If you will remember, you can solve all the questions. Okay, that is not a big problem. You can approach all the types of question, whatever is there in your syllabus or in whatever type of questions are there. You can approach all the type of question. That is not a big problem for you. Clear? Clear? Okay. Now next small topic is very small topic. That is a combination of batteries. Okay. So let us see this topic. How to combine a battery. So suppose there will be two cases I am taking. First case, a series combination. Let us take a series combination. Means suppose that I have a battery with internal resistance R1. Okay, this EMF of the battery is E1. Similarly, I have another battery with internal resistance, because generally they have always an internal resistance. Okay, so this is E2. Okay, similarly I have a battery with internal resistance R2. Correct, like that. And suppose it is up to N. Okay, N batteries are connected. So my question is that what is my E net and R net? Means I want to replace this whole thing by a single battery and single resistance. And this battery has a E net and this is also have a R net. So I can tell you the proper method also, but there is a no need of proper method or proper derivation. We can simply remember my E net will be equal to E1 plus E2 plus E3 plus E4 dot like that. Similarly, what is my R net? If you remember, here the R net will be simple R1 plus R2 plus R3 like that up to Rn plus En, like this. Simple case. Okay, like that. Now in this I want to take an example. Let us suppose example 1, because I want to clear your all the concept in very clear. Like suppose this is 2 volt, this is 3 ohm. Okay, and suppose this is 1 volt and that is suppose 2 ohm. If I want to replace, what I will do, I will write it as E is equal to sir 2 plus 1, because they are in the same manner. Why same manner? If suppose this battery will send the current in this direction, this battery will also send the current in this direction. So whether they are supporting or opposing each other, they are supporting each other. This is a positive, it will send the current in this direction, it will send the current in this direction. So they are supporting or opposing each other. They are supporting each other, both are supporting each other. Okay, they are both are supporting it. I can directly add. So this is my 3 volt. And what is my resistance? Resistance will be simply 3 plus 2, that is 5 ohms. So I will draw the battery whose positive terminal will be this here. Why here? Because I have taken this battery because I have taken current is going in this direction. So this direction I have taken as positive. So obviously this should be positive, this should be negative, and there will be 5 ohm of resistance, and this is 3 volt of battery. But in the same question, let us do some changes. Let us talk about some another example. Like suppose I have a battery of 5 volt and suppose the resistance is 3 ohm. Similarly, I have another battery of 7 volt and suppose this resistance is 1 ohm. Now here how will you draw? See, this battery is going to send the current in this direction, current I1. This battery is going to send the current in this direction, that is I2. So let us understand, basically in this battery the current is entering, and in this battery the current is entering in this manner. So whether they are supporting each other, see, in this manner they are supporting each other, but in this manner they are opposing each other. Okay, they are opposing each other, basically they are opposing each other. In this way they are opposing each other. Here they are opposing each other, you can see, because they both are in opposite directions. So what is my E? E will be simply, now you have to take one direction as positive, another direction as negative. So I am taking, suppose this direction, if I am taking positive, this direction is, I am taking this direction as positive. So what is the value you will get? You will get plus 5 minus 7, that is minus 2 volt. Okay, and what is R? R value is same, 3 plus 1, that is 4 ohm, no problem. So but how will you draw? See, this direction you have taken positive, so obviously you have to draw this as positive terminal, this as negative terminal. Okay, because this you have taken positive, but the result you got is minus 2, so minus 2 volt will be there, like this. Are you getting my point? Minus 2 volt will be there because this is greater value, na? So obviously if you want to make it plus 2, you have to flip it. Okay, and this will be my 4 ohm. So if you want to make it plus 2, what you will do? You will flip it. So you will get something like this. This is my 4 ohm and this will be 2 volt of battery. So you have to flip it to get a positive 2 volt. Basically you should know how to draw the battery. Generally people tell this thing, they don't tell how to draw this battery. Okay, so they don't know the application. Student know the formula, know the thing, but how to apply it they don't know. Basically they don't see the direction and all this thing, and they directly just E1 plus E2 plus E3 like that. But competitive exam do the small changes in this only. Clear? So I hope you clear what how to do the connection in series. Now there is similar manner if I ask you how to do the connection in parallel. Now next case is parallel. Okay, in parallel. If I talk about the parallel combination, basically we have suppose EMF E1 and resistance R1, then we have similarly we have E2 and similarly we have R2. Okay, like that. It is n number of combinations are there up to n times. And here if I ask you what is my E net, so similarly again you have to see the things here. Here the formula is fixed, you have to remember E1 upon R1 plus E2 upon R2 plus E3 upon R3 dot 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 plus En upon Rn divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3 dot 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 plus 1 upon Rn. And what is my R equivalent? How to find R equivalent? So 1 upon R net is equal to, that is 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 1 upon Rn. So if I ask you, let us take one example. Same example I am taking in same manner. Okay. Suppose there is a one battery of 2 volt, okay, and that is connected to 1 ohm of resistance, and similarly I have another battery of 3 volt and suppose it is internal resistance is 2 ohm and they are connected together. And how I will replace it? First what I have to see, first I have to find the E net. Now my question is that whether we will write the formula, that is E1 upon R1 sir, E2 upon R2 sir, divided by 1 upon R1 sir, 1 upon R2 sir, but whether you will always take plus sign here. It will depend upon the direction of current. If you see, this will send the current in this direction. This battery will send the current in this, whether they are opposing or they are like they are helping each other or they are opposing each other. If you will see, they are opposing each other. If they are opposing each other, you will put minus sign here. So it is depend upon you which direction you are taking positive. I am taking this direction as, means this battery I am taking as positive battery, or you can say positive, whatever you want. Okay, so if it is like this I am taking as positive, so obviously you write the, like you write it directly value 2 upon 1 minus, that is 3 upon 2 divided by 1 by 1 plus 1 by, sorry, that is 3 by 2 divided by 1 by 1 plus 1 by 2. So what is the value you will get? If you will calculate, it is 2 minus 1.5, that is how much? 0.5. And here what you will get? 3 by 2. So that value is become how much? That is 1 by 3. This will become 1 by 3. So 1 by 3 volt is the battery. What is R net? That is a parallel combination. So if you apply the parallel combination, you will get 2 upon 3 ohms. So you can replace this with a battery. Okay, and battery value is positive. This direction we have taken positive, so it is 1 by 3 volt with a resistance of 2 by 3 ohm. But suppose if you get the negative value, you just flip it the battery. Simple. You just flip the battery. Simple. Then you can draw. Clear? Any doubt? Now there is something called as a mixed combination that is given in your NCERT. A mixed combination. Just a minute. Mixed combination. What do you mean by mixed combination? Okay, so let us consider that there is a EMF E is there, resistance R is there, EMF E is there, resistance R is there, and this is n times connected to each other. Okay, and then we have another same thing, EMF E R, EMF E R, like this. It is connected up to EMF E R, EMF E and R, that is connected up to m times. Okay, this is connected to n times and this whole thing is repeating to m times, correct? Like this. And you want to replace this circuit to a 1 equivalent. How will you do? So first I will apply the series combination. If I apply the series combination, then how will your circuit will replace? Let us take it